In physics, we often deal with quantities that have both magnitude and direction, such as force, velocity, and acceleration. These quantities are called vectors. They can be represented by an arrow on a coordinate system. The length of the arrow indicates the magnitude of the vector, and the direction of the arrow indicates the direction of the vector. However, not all quantities have both magnitude and direction. Some quantities only have magnitude, such as mass, speed, and temperature. These quantities are called scalars, and they can be represented by numbers or symbols. In this lesson, you will learn how to distinguish between scalars and vectors, how to add and subtract vector using graphical and algebraic method, and how to find the component and magnitude of a vector. You will also learn how to use scalars and vectors to solve problems involving motion. By the end of this lesson, you will be able to apply the concept of scalars and vectors to various physical situations. So, what are the physical quantities? It's any quantity that can be determined and has a measuring unit, such as mass, force, time, velocity, length, displacement, speed, and acceleration. And as we mentioned, we have two types of physical quantities, scalars and vectors. The scalars is the physical quantity that only has magnitude, such as mass, which measuring by kilogram, the time, which measured by second or hour, the length, which measured by meter or centimeter, speed, which measured by meter per second or kilometer per hour. Second, the vectors is the physical quantity that has magnitude and direction. So in order to identify the physical vector quantity, we have to identify its magnitude and direction, such as the velocity, which measured by kilometer per hour or meter per second in a certain direction, the force, which measured by Newton in certain direction, acceleration, which measured by meter per second square or kilometer per hour square in a certain direction, displacement, which measured by meter or centimeter in certain direction. So first, we talk about displacement and distance. So here, the rider, in order to go from home to the factory, he will go in this curved line, which is 200 meters. But if we take a line, a straight line in a certain direction from the home to the factory, will be a 120 meters, and this will be the displacement. So the length of the curved line is the distance, and the straight line from the start point A, which is the home, to the end point B, which is the factory, in the direction AB, is the displacement. So the distance is the whole journey or the actual length of the path that a moving object covers from the starting point to the ending point. And displacement is the distance covered at a certain direction from the primary position or the start position to the final position or the end position. And the amount of displacement is the length of the shortest line from starting point to the end point. So what is meant by the distance covered by the object equal 30 kilometers? The distance is the actual path length. So the actual path length that covered by the moving object equal 30 kilometers. So in this case, we say that this means that the actual length of the path that a moving object covers from starting point to the ending point equal 30 kilometers. And what is meant by the displacement of an object equals 20 kilometers in the west direction? Displacement is the length of the straight line from starting point to the end point in a certain direction. So we say that the straight line in the west direction from starting point to ending point equal to 200 kilometers. So we say that this means that the distance covered in the western direction from the primary position of movement toward the final position equal 200 kilometers. And when the distance, or why the distance is a scalar quantity, Scalar quantity because it only has a magnitude. So because distance is identified by magnitude only. And why displacement is a vector physical quantity? It's a vector because to identify the displacement, we have to identify the quantity and the direction of the movement. So because it's identified by magnitude and direction. When the displacement happen equal the distance covered, so if the body moves from A to B, the distance will equal the length of the line AB. And the distance is the shortest or the straight line in a certain direction from starting point to end point, and the object only move from A to B. So the displacement will equal the distance when the object moves in a straight line. When the object moves in a straight line in one direction. When the displacement of a moving object equals 0, so if the body moves from A to B and then back from B to A, the distance will equal the length of the AB and the length of B from B to A. And the displacement is the length of the straight line in one direction from starting point to ending point, and the object start at point A and end at point A, so it didn't make any displacement. So the displacement of a moving object equals 0 when the object returns to its primary position of movement, where the final position of movement is the same of its primary position. So how can we determine the distance and displacement of a moving object? If the body moves in a certain direction from A to B, the distance will equal the length of AB, and the displacement also will equal the distance or the length from A to B. But in east direction, because displacement is vector and it has to have a magnitude and direction. If the body move from A to B and then return from B to the point C, so the distance will equal the length of AB plus the length of B from B to C. And the displacement is the straight line from starting point to end point. The displacement will be the length from A to C. And in east direction, because we have to identify the direction of the vector. If the body moved from A to B and then from B to C, the distance is the actual length, so it will equal the length from A to B and then from B to C. And the displacement is the straight line in certain direction from starting point to end point. So we draw a line from A to C, and now we have a triangle. And in order to calculate the length AC, we use Pythagoras theorem. So the length of AC will equal the root of AB squared plus BC squared in southeast direction. If the body moves from A to B and from B to C, from C to D, so the length or the distance will equal the length from A to B plus the length from B to C plus the length from C to D. And the displacement will equal the length of the straight line from A to B in the west direction. If the body moves from A to B, from B to C, and from C to A, so the distance will equal AB plus BC plus CA, and the displacement will equal 0 because the primary position of the object is the same as the ending position of the object. Again, if the body moves from A to B, from B to C, from C to D, and from D to A, the distance will equal the length of AB plus the length of BC plus the length of CD plus length of DA. And because the primary position is the same as the end position, so the displacement will equal 0. Again, if the body move in a complete circle, so the starting position will equal the end position, so the displacement will equal 0, and the distance will equal the circumference of the sphere, and we calculate the circumference by the rule 2 pi r. R is the radius of the circle. If the body moves half circle from A to B and from B to C, so the distance will equal half the circumference. So we get the circumference and divided by 2. And the displacement is the straight line from starting point to end point. So from A to C, which is the diameter in east direction. So if the body move in a quarter circle from A to B, so the distance will be quarter of the circumference, and the displacement is straight line from starting point to end point, straight line from A to B. Again, we have a triangle, so we use Pythagoras theorem, which be, so the length of AB will equal the root of AM square plus EM square in northeast direction. And both AM and MB are the radius of the circle. And if the body move 3/4 of a circle from A to B, from B to C, and from C to D, so the distance will equal 3/4 of the circumference. And the displacement is the line, a straight line from start point to end point. So from A to D, again we use the Pythagoras theorem. So the AD, the length of AD will equal the root of AM square plus DM square in southeast direction. Second, we talk about speed and velocity. So the average speed is the total distance covered by the object in 1 second, and the average velocity is the displacement covered by the object in 1 second. To calculate the average speed, we divide the total distance over total time, and the speed only identified by magnitude because it's scalar physical quantity. The average velocity will equal displacement over total time, and it identified by magnitude and direction because it's a vector physical quantity. So what is meant by a body covered 50 meters northward direction in 5 seconds? Because it's the identified magnitude and direction. So this is a displacement, and he gave us time. So we multiply the displacement over time to calculate the velocity. So this object move by a velocity equal 10 meters per second in north direction. So the velocity of the object equal 10 meters per second in north direction. And because the earth rotates around itself, that's affect the wind direction due a force called Coriolis force, and that affect the velocity of the plane. So if the plane moving with the wind direction, it will increase velocity, and if the plane moves in opposite direction with the wind, that will decrease its velocity. So the pilot flying in the same direction of the wind, so they increase velocity and reduce the time of the trip, so they decrease the amount of fuel consumed during the journey. So in this figure, person start moving from point A and return back to the point A, passing by point C, D, and A. So calculate the average speed and velocity. So in order to calculate the average speed, we first need to calculate the distance. So the distance of the object equal 20 meter plus 40 meter plus 20 meter plus 40 meter. So 20 plus 20 plus 40 plus 40 equal, so the distance equal 120 meter, and the speed equal distance over time. So 120 meter over the time will be 140 seconds. So the speed of the object equal 1.857 meter per second. And to calculate the velocity of the object, we need to calculate the displacement. And don't forget that displacement have to have an arrow above them to indicate that they are a vector physical quantity. The body, the starting point of the object is the same as the ending point of the object. So the displacement will equal 0. So the velocity of the object will equal 0 over 140 seconds equal 0. In the opposite figure, a body covers 30 meters northward within 30 seconds. So northward from A to B, 30 meters in 30 seconds. And then 40 meters eastward within 20 seconds. So 40 meters from B to C in 20 seconds. Calculate the total distance. Total distance means the length of the whole journey. So from A to B and from B to C. So it will be 30 plus 40 equal 70 meters. And the average speed. So the average speed is the total distance over total time. So 70 and the total time is 50. So equal 1.4 meter per second. The displacement is the length of the straight line from starting point to end point in certain direction. So we draw straight line from A to C. And to get the length of the AC, we have to use Pythagoras theorem. So the length of AC equal the root of AB square plus BC square. So AC will equal 30 square plus 40 square equal 50 meter. So the displacement equal 50 meter in the northeast direction. So the velocity equal displacement over time. Displacement which is 50 meters in northeast in the total time which is 50 seconds equal 1 meter per second east northeast direction. In the opposite figure, the car start motion from point A to point B, then from B to C, then from C to D, and from D to E, from E to F. Calculate the total distance covered by the car. So the total distance is from A to B 202 kilometers plus from B to C 5 kilometers plus CD 1 kilometer plus from D to E 3 kilometers plus from E to F 1 kilometer. So the distance equal 15 kilometers. The displacement covered by the car is the straight line from starting point to end point, so from A to F, which will be 2 kilometers because from we subtract the PC from ED. We only need to take this line from A to F, which will be 2 kilometers in the west direction. The velocity if you know that the total time spent by the car equal 1 hour, so velocity equal displacement over time. So the displacement is 2 kilometer over 1 hour equal 2 kilometer per hour in west. In the opposite figure, car start motion from A to B, then from B to C, then from C to D, from D to E, and then finished in point F. Calculate the total distance. So we take the length of the whole route. So 2 kilometers from A to B, 5 kilometers from B to C, 1 kilometer from C to D, 3 kilometers from D to E, and 1 kilometer from E to F. So the distance equal 15 kilometers. The displacement done by the car, so displacement equal the length of the shortest line from starting point to end point. So from A to F will equal 5 minus 3 kilometers equal 2 kilometers in the east direction. And calculate the velocity if you know that the total time spent by the car equal 1 hour. So velocity equal distance over time equal displacement over time. So the velocity, the displacement equal 2 kilometers. The time is 1 hour equal 2 kilometers per hour in east direction. In the opposite figure, a body moves in a circular path. Its radius 7 meters from A to B and from B to C. Calculate the distance and displacement. The distance is the actual path, and because the object move half a circle, so the distance will be half the circumference. So first we need to calculate the circumference. So the circumference equal 2 pi r. So equal to 22 over 7 multiplied by the radius, which is 7, equal 44 meter. So half the circumference, so the distance will equal 44 over 2 equal 22 meters. So the displacement is the straight line from starting point to end point. So it will be the diameter of the circle. And the diameter equal to radius. So equal 2 multiply 7 equal 14 meter in east direction. In the opposite figure, an object is moving from point C to point M, passing by the point D and point F in 5 seconds. Calculate the distance. So the distance is the length of the whole route. So the distance will be from C to D plus from D to F plus from F to M. So from C to D is 8 centimeter. From F to M is 7 centimeter. So what is the distance from D to F? From D to F is a half circle. So we need to first calculate the circumference of the circle. So the circumference of the circle equal 2 pi r equal 2 multiply 22 over 7 multiply 7 equal 44. 4, and because it walked or moved half a circle, so we multiply the divide 44 by 2 equal 22. So from D to F is 22 centimeter. So the distance will be 37 centimeters. The displacement of the object is the straight line from starting point to end point. So from C to M equal 8, plus from D to M, it's also a radius, so which equal the length from M to F equal 7 centimeter, equal 15 centimeter east direction. The average speed, the speed equals distance over time. The distance was 37 centimeter over time is 5 seconds, equals 7.4 centimeter per second. And the velocity equal displacement over time. So the displacement is 15 centimeter east in 5 seconds, equal 3 centimeter east direction. Centimeter per second east direction. In the opposite figure, car moves in a circular path whose radius is 10. So the radius is 10 to 10 centimeter and 10 centimeter. So the diameter will equal 20 centimeter. Car movement change as in the opposite figure. So from A to B, from B to C, then from C to D. Calculate the distance and displacement. The distance is the whole path, so will equal from A to B plus from B to C plus from C to D. So from A to B is quarter of the circle, from C to D is also a quarter of the circle. So the body move half a circle plus the diameter. So anytime you have a circular path, first thing to do is to calculate the circumference of the circle. So the circumference of the circle is 2 pi r equal 2 multiply 3.14 multiply the radius is 10 equal 62.8. Then determine how much of the circle the object move. Half a circle, quarter a circle, 3/4 of a circle. So in this figure, the object move quarter plus quarter. So the object move half a circle. So from B to C will be the 62.8 over 2 equal 31.4 centimeter. So will be 31.4 from A to B plus B from C to D is 31.4 plus the diameter from B to C equal 20. So the distance will equal 51.4 centimeters. Then calculate the displacement. The displacement is the straight line from starting point to end point. So from A to D, and from A to D is also a diameter. So it will equal 20 centimeter in south direction.